right, so I'm just giving some very basic information. Yesterday we talked about how we can compare, usually we compare p-value to alpha, but we can also compare test statistic to critical value. And then I had a good question about this, and I thought I want to go ahead and do it as a group while I'm thinking about it. We did one with Z, but it works the same way with T. So all I'm giving you is this information. So this first line would tell me what? Just this piece right here would tell me what? Which way I'm shaded in this one tail. So that shows me less than, so it's here. And when I'm doing it the reverse way, this is my rejection region with alpha being 0.025. Why did I give you the S equals 4? To know that you're doing T. And because you're doing T, why did I give you N? So just making sure that we understand how to find that critical value. It's not something that you would have to do that much, but just understanding that it would work the same way with T's. So I am now finding where is this line to separate between my rejection region and not the rejection region. So degrees of freedom equals 19. So let's look at the chart first. So how about your purple sheet, whatever the color you want to call it. So I know that I am where on this sheet? DF equals 19. So I'm down to that line. And then from there, what else do I know? Tail probability is 0.025. And when those meet, you meet at what value? 0.93? Yeah. All right, now, but look at my picture. So even though this is what the chart gave me, what is my actual critical value? And that doesn't always happen with T's, it's just because it's less than. If I use the calculator to do that, how would I have done that?
Second distribution, 4.
Second distribution, and what is 4?
Inverse T.
I have some people who have used this and some people who haven't used it as much. This is the one where, was that hard to find that in the purple sheet? No. So some people just stop there and don't use calculator. I don't care either way. If you use this, what does it ask you for when you use inverse T?
Area.
And what is the area shaded for to that critical value? And what's the other thing it asks for? Which is, and then you're going to type that in, and what's it going to give you? And so it already gives you negative because you're saying you only wanted the area up to that to be this much, so it's starting from the left. So this method just gives you the negative, whereas the other one I had to put it there. Does that make sense? All right, so just understanding that this thing applied the same way with T's as it does with Z's. Okay, our second thing. I want to run one in the calculator with means. I can't remember if we've done one in the calculator with means or with but if you've done one, I mean, even if I said go do it right now and you haven't done one, y'all would be fine with it. Let's say our our alternative hypothesis is that mu is less than 7. Our x bar is 6.7. Our S is 1.2, and our N is, we'll just say 20 again. All right, so first let's go over actually running the entire test in our calculator. I think we did one of these with means. It's been a while, but just going over one real quick. So what's the very first button that I push? Stat. I'm just getting rid of all that. Okay, so stat, which gives me these options. Where do I go from there? Tests. Well, the first 6 options are all tests, which is where we are this chapter. 3 and 4 are 2 sample, which is not where we are this chapter. So this chapter we're only 1, 2, and 5. So 5 is the one if we're dealing with proportions. Right now it's Z or T. Am I dealing with Z or T? T, because there's an S. So I'm going to 2. And I get 2 options at this point. If it is data or stats, data would mean I have a list because it asks me for a list. Stats, it doesn't ask me for a list because I don't have one. So our mu naught is 7. Our X bar is 6.7. Our S is 1.2. Our N is 20. And our alternative direction is less than just this one. So then I just hit calculate after I've typed all that in. And it's going to give me, what is T? What do we actually like write on our paper for what is T? The test statistic. What is P? The P value that goes with that test statistic. And then X bar SN, we already typed all that in anyway. So we end up getting a test statistic of negative 1.118 with a P value of 0.1387. So skipping ahead to what we do with that, let's say our alpha was 0.05, so they give you one. So P value was 0.1387. I compare that to my alpha of 0.05, and I know that this is what? The way I usually write it.
It is not.
It is not less than 0.05. And if it is not less than, that means we what?
Failed to reject. They don't have that.
So that's just whatever the calculator thing. Now, this last piece is something that I haven't talked about yet, but I shouldn't need to, that I want to explicitly go over where this comes from. So let's talk about our chart thing again. What's here? Which means what's here? But now, really, we end up usually saying that this is what? What are my 2 options, regardless?
Reject or failed to reject. Or not reject.
So just while we're here now, let's cover a couple things. What is this left path called? Type 1 error. What's my last path called? This one isn't a name, but what do I call this one? The ideal scenario, the way I call it. Now, the reason I call it ideal scenario is if you take someone to court, why do you take them to court?
Because you want to prove that they are.
Because you want to prove they did it, right? You think they're guilty. So this is like saying you took them to court and they were convicted. It's like I call it the ideal scenario because if you're putting in the work for it, that's probably what you're trying to get out of it. Now, probabilities of these, what is the probability of a type 1 error called? What is probability of a type 2 error called? Alpha comes before beta, 1 comes before 2. This ideal scenario path, what is the name of the probability for that path? So this is just reviewing stuff. Beta and power both come off this same branch. So what is their relationship to each other?
1 minus beta.
They're inversely related to 1 minus beta. And then you can't just say you want both of your errors to be unlikely. There's a risk reward involved there. So what's the relationship between alpha and beta? Also inversely related. Okay, so back to this one. We failed to reject the null hypothesis, right? Which means out of this whole tree, I either was here or here, but I'll never know which one I was actually on, right? Because I'll never know if the actual null hypothesis is true or not. So if I ask, what is the only possible error we could have made, what would the answer be?
Type 2.
Type 2. Because I know one of these two, here I'm right, here I made a type 2 error. So, in a scenario where the only possible error we could have made would be a type 1 error, would be if what?
We rejected the
So at any point in time, if our conclusion, our decision is to reject the null hypothesis, the only possible error we could have made is a type 1. Does that make sense? And so like, I think you could think through this without me writing it up here, but I wanted to just be explicit and write it up here. Questions about anything like with what I kind of talked through up here?
Could you re-explain type 2?
What about it?
Like what a scenario would be that there could only be a type 2 error, not type 1.
Okay, so if literally in my conclude, I choose to fail to reject the null hypothesis, that means I'm either here or here.
Mhm.
Well, here is not an error, and here is an error. So if my conclude was failing to reject, the only possible error I could have made is a type 2.
Okay.
Does that make sense? Any other questions right now for the good of the whole? Alright,